In an electric motor, the magnetic forces of repulsion and attraction cause the motor to turn. To illustrate the basic operation of an electric motor, a bar magnet is suspended within the magnetic field of a horseshoe magnet. The horseshoe magnet does not move and is called the stator, or stationary part of the motor. The bar magnet, positioned in the magnetic field of the horseshoe magnet, has the ability to rotate and represents the rotor, or the portion of the motor that turns. Since like poles repel each other, the bar magnet will rotate until the north pole of the bar magnet is lined up with the south pole of the horseshoe magnet. Once the opposite poles line up with each other, the magnetic attraction between the opposite poles will cause the bar magnet to stop. In order for the bar magnet to continue to turn, the poles of the horseshoe magnet must change. This will cause the bar magnet to turn another 180 degrees. To keep the bar magnet turning continually, the horseshoe magnet must constantly change its pole configuration. This is the same concept on which the electric motor is based. At the beginning of a cycle, the poles of the stator would be configured as shown here, and the rotor will turn so that its north pole aligns itself with the south pole of the stator. During the second half of the cycle, the polarity of the stator poles is once again reversed, causing the rotor to turn so its north pole is once again aligned with the stator's south pole. The polarity of the stator poles continues to change, causing the rotor to turn as long as the motor is properly energized. The shaft of the motor is connected directly to the rotor, enabling the motor to do useful work, such as moving air, water, or refrigerant through heating, cooling, and refrigeration equipment. The speed at which a motor operates is determined by the number of poles it has. The more poles a motor has, the slower its operating speed will be. This formula determines motor speed based on the number of poles. A 4-pole motor will therefore have a calculated speed of 1800 revolutions per minute. Next, we'll examine a number of motors that have different running and starting characteristics and perform a number of different tasks in our industry.